All right, hello everybody. Welcome to Math with Miss Leslie. Oh my God. I know we're probably going to watch this like together as a class, so that probably just was really awkward for me. It's going to be awkward when I have to watch this. It's okay. So we are starting this hair. Like seriously though. Yeah, that's what we got. It's Saturday night at 9:30 p.m. So we're talking kind of quiet because the baby's sleeping. Okay, anyways, um, we are starting Unit 7 today, which I think a lot of you will maybe like more than our last unit. Unit 6 is it's tough, right? You have a lot of stuff going on. You have factoring, you have solving pieces, you have inverse trig, you have unit circle stuff, you have the identities that you just learned. So it kind of everything kind of culminates into this really tough unit, I think. Um, but Unit 7, I think, is not a bad unit. We are going to touch on some things that you guys have never seen in Unit 7, but this is kind of our applied mathematics kind of unit. So it's our last official trig unit for the year. So that's, I guess, something to be excited about. I know it's like the fourth quarter and it's going to be 4 weeks, so it's basically the end of the year. But it's a nice unit. It's easy, I think, and it introduces you guys to some newer things that you haven't seen before. The math, I think, is relatively easy. Not really any factoring going to be happening. Definitely still trig, but at least there's no like factoring, I guess. I don't know. All right, so here we go. So today's stuff is something that I think some of you might have seen in geometry. Maybe not. I know some geometry teachers at Ballard cover the law of sines, but maybe not everyone. So we will obviously go over it, but this is definitely something that you could find yourself doing in a geometry class. So we've talked a lot in this class about finding like missing sides of a right triangle, all right? And we've used like sine, cosine, tangent, secant, cosecant, cotangent, right? We've used them to like set up ratios with right triangles and find like, sine is opposite over hypotenuse. And like when you have a right triangle, you can do that because you have a hypotenuse. But there is actually a way to find missing sides and angles of non-right triangles using trig. And one of those techniques is the law of sines. So in this unit, we are going to be dealing with non-right triangles. Which if you think about real life, a lot of the times you don't have nice, beautiful, pretty right triangles. You have oblong, weird, triangles like this one, right? Where you don't have a right angle. So this one, definitely there are more uses of the law of sines in real life. So let's check out what the law of sines is. So here we have a triangle. Now, just to go over a couple naming rules for triangles. So generally the vertices of your triangle, so the corners, are going to be capital letters. And then the side opposite of an angle will have its lowercase letter equivalent. So if you look here, we have angle A, and then side A is directly opposite angle A, right? Same thing happens over here. So side B and angle B, right? They're opposite each other, all right? And then just to do all of them, right? We have angle C, and then across from angle C is side C. So this is a common naming practice when we're dealing with geometric shapes. So this is an important thing to keep in mind. So we're going to be using a lot of, oh no. Da, 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 da. All right, we just have to undo. That's cool. All right, so this is a very common naming structure, right, for shapes. So this is something we're going to be using a lot. So the law of sines is actually easy to kind of derive. So we're going to just kind of figure out where it comes from. All right, so if you didn't know the law of sines, a general technique for finding missing sides and angles in a triangle is to just make it a right triangle. So if we were to drop down this, what we call a perpendicular, and call this h for the height, right? This is the height of our triangle. All right, so if we have this height here, all right, we can kind of set up some like ratios using sine, right? So let's look at angle B. All right, so here's angle B. Oh no. Right? So if I wanted to find, say, the sine of angle B, I could say that sine of B equals, so opposite, that would be H, over the hypotenuse of this little right triangle, right here, which is C. All right, and just to get rid of the fraction, let's go ahead and just multiply both sides by C. All right, so we have C times sine of B equals H. All right, let's try the right triangle on the other side. So let's look at this right triangle. All right, and say we wanted to find angle C. All right, again, using sine, we could say that the sine of angle C, again, it's opposite over hypotenuse, so H over my hypotenuse, which in this case is B. All right, and again, we want to get rid of our fraction, so we just multiply both sides by B. So now we have B sine of C equals H. This should be like a lowercase. I don't know why it looks like an uppercase. There we go. All right, well, there's something that we have in math called the transitive property. It says if A equals B and B equals C, then A equals C. Well, look, these two things both equal H, which means they then must be equal to each other. So C sine of B has to be equal to B sine of C. All right, now you might be thinking, Miss Lashley, this is wild. Why are we doing this? Well, this is basically what the law of sine says. All right, all we have to do is get the side B with angle B and side C with angle C. So I'm just going to divide this side by B and divide this side by C. Hold on, we should probably do that in single steps so you guys don't be like, that's wild. All right, so we're going to divide that side by B. All right, and when we do one side, we have to do the other side. All right, and then just in a different color, I'm going to divide by C on both sides. So then those will cancel. So this leaves me with the sine of angle B over side B equals the sine of angle C over side C. All right, and this is basically the law of sines. Now, you're probably wondering, what about angle A? Well, angle A also works the exact same way. We could turn the triangle sideways if we wanted to and do angle A also, but we don't need to. The ratio is the same, so sine A over side A. So this right here, this is your law of sines. Right? In geometry, we call this a proportion, right? When you have a bunch of fractions equal to each other, it's called a proportion. When you did similar triangles, you actually use proportions all the time to find missing sides and angles. So this is same kind of idea, right? So we're just doing a bunch of fractions equal to each other, right? So these are basically telling us that the sine of an angle divided by its side is equal to any other sine of the angle divided by its side. All these ratios in a triangle should be equal to each other. All right, so this is one technique that is going to allow us to find some missing sides and angles. All right, so let's take a look at a problem. Okay, so scroll down. All right, so it says, use the law of sines to find the missing sides and angles. All right, so our rule says we have to have an angle and its opposite side. So here's our law of sines. All right, so let's just write it out. So sine A over side A equals sine B over side B, which equals sine of C over side C. That's our law of sines. All right, so now we're going to kind of see what we've got going on here. We are going to have to use a little bit of triangle rules. So hopefully you guys remember your triangle rules. It's not like a lot of triangle rules, but there's a couple that are going to come into play here. So the first one is something about all three angles of a triangle. So if you look here, we know that one angle is 64, one angle is 45. We don't know angle C, but in any triangle, all three angles should add up to 180 degrees. That is a standard rule for all triangles. All right, so that's something we should remember, hopefully, from geometry. So right here, so all three angles add to equal 180 degrees in all triangles, okay? So we can easily find that missing angle C by adding up 64 and 45 and then subtracting it from 180. So that's what I'm going to do first. So we have 64 degrees plus 45 degrees gives us 109. All right, and then subtract from 180. And that's going to give us 71. All right, so our missing angle right there is 71 degrees. All right, so that's an easy thing that we can do first, and we did do first. All right, so now I'm going to move this. I probably should have just done this over here. That's okay. Now I moved it over. All right, so now what we want to do is we want to start setting up these different ratios. All right, and we're just going to plug in the information that we have. So sine of angle A. Well, we know what angle A is. It's 64. So we have sine of 64 divided by side A, which we don't know. So we're just going to put an A because we don't know what side A is. All right, equals, all right, sine of B, which we know angle B is 45. So we can plug in a 45 for angle B. All right, but again, we don't know what side B is, so we're just going to put a B there to represent that. And last, we have angle C, which is 71, divided by side C. Now, we do know side C, which is good because we needed to know at least one side. Otherwise, this really wouldn't work out for us. All right, and so we are going to plug in a 20 for our side C length. All right. Now, in order to solve these different proportions, we are just going to pick, we're going to have to use the sine C piece to find our missing variables. So it doesn't matter which one you find first. You can do A, you can do B, doesn't matter, but you're going to pick one of the other ratios to pair up, and then we're going to cross multiply and we're going to solve. All right, so I'm going to find A first just because alphabetically, I don't know, right? So I'm going to take sine of 64 divided by A, and I'm going to equal it to the sine of 71 degrees divided by 20. All right, I'm going to cross multiply. So I'm going to multiply both sides by 20. Those are going to cancel. And then I'm going to multiply both sides by A. Right, so that's cross multiplication, right? You just kind of multiply across. All right, some teachers also teach that you can like multiply along the diagonal like this. I don't know, that's how I think like elementary school teacher taught us. She was like, highlight your things and just multiply straight across. Yeah, you could do this, right? This is what you do when you have an equal sign in between them. This is not, if this was just sine 64 times sine 71, whatever, you don't do this with straight across multiplication. This is only when you're doing equals because it's like you're multiplying by the denominators on both sides. All right, anyways, so we end up with 20 times the sine of 64 equaling A times the sine of 71. All right, our goal is to solve for A, so we are going to divide both sides by the sine of 71. Cross, cross. All right, and now we're going to go to our calculator. Duh. All right, and so we have right now A equals 20 sine of 64 divided by the sine of 71. And we're going to plug that in and see what we get. Now, because these are degrees, we do want to make sure before we go any further that our calculator is in degree mode. Otherwise, you're going to get wrong answers. All right, so 20 times the sine of 64 divided by the sine of 71. And this is going to give me 19. And generally, I usually say like round to like the nearest decimal place, like to the tenths. So we'll just do 19.0, maybe to the hundredths, right? 01, because I don't like to have it just be like a 0. All right, so side A is 19.01. All right, so last thing we need to do is figure out side B. All right, so we're gonna use that same sine of 71 over 20 because there was no rounding, right? You always wanna go back to the original like information you were given. I wouldn't wanna use this A value to solve for side B because I'm gonna not get an exact answer. We always want it to be as exact as possible, means we wanna kind of do as much as we can without using something that's been rounded. So I'm going to go ahead and to find my side B, I'm going to set it up like this. So I'm going to do sine of 45 degrees over side B equals, and then again, like I said, I'm going to use that sine 71 over 20. Okay, so again, we are going to cross multiply. All right, so it's going to give me 20 sine of 45 degrees equals B sine of 71 degrees. It'll catch up. All right, and now we want to divide both sides by sine of 71. Okay, so now we're left with B equals 20 sine of 45 divided by the sine of 71. And so we're going to go to our calculator, and we should now be in degree mode, so we don't need to change it. And we're going to type that in, 20 sine 45 divided by sine 71. And this gives us 14.96. So 14.96. All right. And that is the end of the problem. All right, so remember a couple things, right? So the 3 angles of a triangle should always add up to 180, and that's going to be very helpful. All right, and then I always think it's a nice idea to set up the full proportion first. So like sine of A over A equals sine of B over B equals sine of C over C, plugging in the values that you know, and then go from there. Pick two that you know you have enough information for, and then cross multiply and solve. All right, that is the law of sines. I hope that was helpful. And yeah, now I guess you can start on your classwork.